In this video, I'll be explaining how to do the chemical reactions practice test. Your first set of questions ask you to balance some equations. This is some simple stuff. You just write coefficients in the blanks so that you get the same number of elements on each side of your arrow. For the first problem, we see on the left side of the arrow there's a SN or 10, and on the right side there's a 10. On the left side we have 2 sulfurs. On the right side there's just 1 sulfur, so we'll put a 2 right there. That gives us 2 sulfurs. That also gives us 2 times 2 oxygens, or 4 oxygens plus 2 oxygens, so 6 oxygens on the right, 2 oxygens on the left. Put a 3 right there. 3 times 2 is 6 oxygens. For this next problem, we have 1 aluminum, 1 aluminum. We're going to skip the hydrogen for a minute. See right here we have a chlorine and 3 chlorines. So if we put a 3 right there, then that gives us 3 hydrogens and 2 hydrogens. Well, that's going to be problematic because what times 2 is 3? Well, that's 3 halves, right? Well, we can't leave fractions in there, so we got to multiply everything by 2 to get rid of that denominator. So put a 2 right there. We change that 3 to a 6. We put a 2 right there. And we change that 3 halves to a 3. In this problem, you'll notice there's a cobalt on each side, a carbon on each side, and 3 oxygens on each side. This reaction is already balanced, so don't do anything. This next problem says, will the following reaction occur? Explain your answer. This reaction, where we have one reactant by itself, an element by itself, and we have a compound, that is a single replacement reaction. To know if a single replacement reaction occurs, we need to reference the activity series on our reference tables. So we're looking to see if the element by itself is higher on the activity series than the element in the compound. So if we look in the activity series, I see silver is way down here near the bottom. It's lower than copper. The thing by itself, silver, is lower than the thing in the compound, copper. So in that case, no. And the explanation is that silver is lower than copper on the activity series. So now we're going to move on and tackle some more problems. This one says, write balanced equations for the following. Barium nitrate and sodium sulfate solutions are mixed. So first we need to correctly write some chemical formulas. Barium is Ba. Barium has a +2 charge. Nitrate, we check over here, nitrate is a minus or -1. So barium's a +2, nitrate's a -1, so it's BaNO3 and it combines with sodium sulfate. Sodium's in group 1, it's a +1 charge. Sulfate, a polyatomic ion, not to be confused with sulfite or sulfide. Sulfate, SO4 with a -2 charge. So we need 2 sodiums, it's +1 and -2. That's going to make, this is a double replacement reaction. We have 2 compounds. For double replacement reactions, they all follow the template. AB plus CD makes AD plus CB. So AB plus CD makes AD, barium sulfate. Remember, barium's a +2 charge and sulfate's a -2, so it's BaSO4, plus CB, sodium nitrate. Sodium's a +1, nitrate's a -1. We don't just carry these 2's over and make it Na2NO3. So sodium's a +1, nitrate's a -1, it's just NaNO3. Then we balance the equation by putting a 2 out there in front of the sodium nitrate. Now the only way this reaction even happens is if we make a precipitate, or water. So we need to precipitate, something that's insoluble, or we need to make water. And in this case, we look at barium sulfate. All sulfates are soluble except barium sulfate is not. So barium sulfate is a precipitate. So we do get a chemical reaction, which is good. For number 8, gives us lithium plus chlorine. Here we just have two elements. The only thing you can do with two elements is add them together as a synthesis reaction. So we're going to form the binary compound between lithium and chlorine. Now I know some of you may be tempted to just say, oh, it's LiCl2 and just carry the 2 over, but you can't do that. You got to balance the charges. Lithium is in group 1, so it's positive 1 charge. Chlorine is in group 17, it's a negative 1 charge. So the formula is just LiCl. So since we've got this 2 chlorines over here, now we balance by putting coefficients or numbers out in front. So 2 chlorines on that side of the arrow, so we put a 2 right there. That gives us 2 lithiums and 2 chlorines. So we squeeze a 2 in over there, and now it's balanced. Number 9, magnesium hydrogen carbonate. This is a decomposition reaction. By the way, one thing I can do down here, we already said that number 8 was synthesis. Number 9 is decomposition, because if you only have one reactant, then the only thing it can do is break apart. Now when it comes to decomposition, we should always check our rules to see if we have a special rule for this type of decomposition. We're probably not going to break this apart into magnesiums and hydrogens and carbons and oxygens. Hydrogen carbonates decompose into carbonates plus water plus CO2. We'll deal with the carbonate in a minute, but I know how to write the formula for water. I know how to write the formula for carbon dioxide. So this is going to make magnesium is our metal, carbonate. Magnesium is a plus 2 charge, and carbonate, if we check our polyatomic ions list, is a negative 2 charge. So it's just MgCO3. So we've got our formulas written correctly. Now let's see if it's balanced. Magnesium on each side, 2 hydrogens, 2 hydrogens, 2 carbons. There's a carbon there and a carbon there. And here we have 6 oxygens. 3 plus 1 plus 2 is 6. So it's balanced. For number 10, we've got iron all by itself, and we've got a compound. This looks like it's going to be a single replacement reaction. So we're going to write that down here while we're thinking about it. Since this is a single replacement reaction, we need to see if it's going to occur by seeing if the element by itself is higher than the element in the compound on the activity series. And we find iron, which is by itself, is higher than copper, so a reaction will happen. This is going to make iron nitrate plus copper. Now in this case, we don't know the charge of iron because iron is one of our transition metals, and we have no way of figuring out what it was on the other side of the arrow. I'm not going to give you a problem like this on your test where you have to just guess what the charge of iron is. So we can just leave it alone and say it's a 1, or we could say it's iron 2 nitrate or iron 3 nitrate. Who really knows? You're not expected to be able to guess that. If we leave it as iron 1 nitrate, then we need to put a 2 right there and a 2 right there to balance the equation. Number 11, this is another decomposition. Don't be fooled by decompositions. Make sure that you check your rules. This is copper 2 hydroxide. Hydroxides decompose into oxides and water. This is going to make copper 2 oxide. Now I know it's copper 2 because hydroxide, remember, is a negative 1 charge. We have 2 of them, so copper was a plus 2. It'll keep that charge over here with the plus 2. Oxygen, because this makes the oxide, is a negative 2 charge, so it's just CuO. And if we look, 2 oxygens, 2 hydrogens, 1 copper, this equation's balanced. That's all we have to do. Number 12, yet another decomposition reaction. Metallic chlorates, like this potassium chlorate, just keep in mind ClO3 is chlorate, they decompose into metal chlorides and oxygens. It's going to make potassium chloride, potassium's a +1 and chlorine's a -1 charge, so KCl, plus oxygen. And oxygen's a diatomic element. It's one of those 7 diatomic elements, so it's O2. Then to balance this, got a potassium, we've got a chlorine on each side, we've got 3 oxygens here and 2 oxygens there. The only way to get those equal is to get 6 on each side. So put a 2 in front of potassium chlorate, a 3 in front of the oxygen, and we also need to put a 2 in front of the potassium chloride. And that was another decomposition. Number 13, this is combustion, because it says this undergoes combustion. So we take C3H8. And a combustion reaction says this hydrocarbon reacts with oxygen. So we're going to have to add in oxygen. And it makes carbon dioxide and water. So I'm going to write carbon dioxide and water. That's all there is except for balancing. 3 carbons, 1 carbon, so we'll put a 3. 8 hydrogens, 2 hydrogens, so put a 4 because 4 times 2 is 8. Over here we have 2 oxygens. Over here we have 6 plus 4, which is 10. So what times 2 is 10? 5. And we're done with that one. Now we're going to move on. We're going to omit this particular problem right now. Don't worry about that one. Number 20. Writing a balanced net ionic equation for this is pretty easy because it already has our precipitate labeled for us as being the solid that forms. Because iron phosphate, if we check our rules, would be a precipitate. So all we have to do for a net ionic equation, our product is FePO4, and we break it apart into irons and phosphates, and we should probably put the charges on them. Since it's an ionic equation, remember an ion is something with a charge. Phosphate has a -3 charge, and since phosphate was -3, the iron was a +3 charge. That's our net ionic equation. Number 22, we're back to writing and completing some balanced equations. Bromine plus zinc iodide. This is going to be a single replacement reaction, so we'll check our activity series. Bromine is a halogen, so we compare it to the other halogen on the list, iodine. Bromine is higher than iodine. So we're going to end up with iodine by itself plus zinc bromide. Zinc is a +2 charge because that's one of those you're supposed to remember. It's always a +2. Bromine is a -1 charge, so it's going to be ZnBr2. And this equation is already balanced. We don't have to do anything else. Number 23. This is going to be a single replacement reaction, just like 22 was, except here we have a metal as by itself. We consult the activity series of metals. Lithium is higher than copper. The thing by itself is higher on the list. In fact, it's the highest thing on the list. So we definitely get a reaction. That's going to make copper all by itself plus lithium sulfate. Lithium is a +1 charge. Sulfate is a -2 charge. So that's going to be Li2SO4. And then to balance it, we put a 2 out in front of the lithium. For number 24, this is going to be a double replacement reaction because we have 2 compounds. So they're going to follow the template that we've seen before, where AB plus CD makes AD plus CB. So this is AB plus CD. Well, that's going to make AD, magnesium hydroxide. Magnesium is a +2 charge. Hydroxide is a -1, so it's MgOH2 plus sodium sulfide. Sodium is a +1. Sulfur is a -2 charge. So that's going to be Na2S. And this equation's not balanced, but we have 2 hydroxides and 2 sodiums over here. So we'll put a 2 right there in front of sodium hydroxide. Number 25, we have a lead acetate compound. This is lead 2 acetate. And we've got potassium iodide, another double replacement. We follow that same template. AB plus CD makes AD plus CB. So that's going to make lead iodide. Now I know iodine is a -1 charge. Now to figure out the charge of lead, it's going to be whatever it was over here, it'll keep the same charge. For all double replacements, charges stay the same. So acetate is a -1 charge, and since there were 2 of those with our lead, over here lead was a +2, so over here lead's a +2. So this is going to be PbI2. I'm going to erase those charges just to get them out of the way. And then the other thing we're going to make is potassium acetate. Potassium in group 1 is a +1 charge, and acetate, as we just saw, is a -1 charge. Then it says, in reactions 24 and 25, circle the precipitate. So we check our solubility rules. In 24, we form magnesium hydroxide. All hydroxides are insoluble except group 1. Magnesium's not in group 1. It's in group 2. Strontium, barium, and ammonium. So that means magnesium hydroxide is our precipitate. So draw a circle around it. And number 25, we got lead 2 iodide. All chlorides, bromides, and iodides are soluble except silver, lead, and mercury. So that means this lead iodide is not soluble. It's a precipitate. By the way, these other compounds, since they have something from group 1, they're always soluble. So that's never a precipitate if it's got an alkali metal in it. Problem 22 says circle the reactants. Well, that is the things on the left side of the arrow. So I'll just draw a circle around those. Then 29 and problem 23, circle the products. It's these. And number 30 says an aqueous solution of magnesium hydroxide is mixed with aqueous copper chloride. What observation will be made to confirm a reaction occurred? Be specific. Now, if you remember, the way that we know a reaction has taken place is if there's a color change, if it absorbs or releases heat, if it forms a gas, or if there is a precipitate. Now, the one of these that's easy to check is we can find out if we make a precipitate. Because here's the thing. If you take magnesium hydroxide and you mix it with copper chloride, that's AB plus CD. This is a double replacement reaction. Our products would be magnesium chloride and copper hydroxide. I'm going to imagine this is probably going to be copper 2 chloride and copper 2 hydroxide. Don't worry about how I know that. But let's see if we make a precipitate. Magnesium chloride. All chlorides are soluble except silver, lead, and mercury. Not a precipitate. Copper 2 hydroxide. All hydroxides are insoluble except group 1 strontium, barium, or ammonium. So that's a precipitate. So what observations would be made to confirm a reaction occurred? A precipitate of copper hydroxide forms. And that completes this little practice test.